Hi everyone, my name is Ida Salim, and today I'm going to talk about dimensional analysis, a method used to convert units. So here we're going to talk about the meter stick, and basically let's think of this as 1 meter, and we know that in 1 meter so this whole thing is 1 meter and we have 10 decimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just kind of sketching it. Right? Pretend they're even, but you know what I mean. My whole point of this slide is to just illustrate that deci means 10, centi is 100, and milli is 1,000. So 1 meter is 10 decimeters, 1 meter is 100 centimeters, and 1 meter is 1,000 millimeters. So this chart basically is your unit chart that will help you convert from units. As you go, this is your base 1. As you go up, it gets larger. And as you go down, it goes smaller, right? What I would pay attention most on is probably all of these and kilo, because those are the ones that are most commonly used in common chemistry textbooks. So over here are the most commonly used conversion factors. They're important because it's going to be helpful when you start converting units. I would commit these to memory. It's very helpful. What this means applies to mass and volume units. It could be, 1 meter, 1 decimeter, 1 meter is 100 centimeters. I mean, I'm not going to read it, but if I were you, I would really recommend committing this to memory. One thing I do want to point out is that with density problems very often, this is 1 milliliter is equal to 1 centimeter cubed, okay? So that's important when you're talking about density, okay? Yep, that's all I have to say with this. So let's practice a little bit about converting units. So what are the conversion factors necessary for converting grams to kilograms? Well, remember, kilo is 1,000, right? So that means in 1 kilogram, there is 1,000 grams, okay? So that would be the conversion unit that would be necessary to know. If you're going from liters to milliliters, you know in 1 liter is 1,000 milliliters. And this is coming right from the previous slide. You just have to be really understanding of prefixes. Milli also means 1,000. Milli and kilo means 1,000. Inches to centimeters, the conversion factor you would need is 1 inch is 2.54 centimeters. So it's coming from the previous slide that I really recommend to commit to memory. How many milliseconds are there in 15 years? This is a really cool question because you're going to have to learn how to convert using dimensional analysis. So let's begin by, you always start off with the number they give you. You have 15 years. I'm going to say why. Now I'm just going to start canceling out units until I get to milliseconds. So I know that in 1 year, there's 365 days. I know that in 1 day, there is 24 hours. I also know that in 1 hour, there's 60 minutes. I know that in 1 minute there's 60 seconds. And I know in 1 second is 1,000 milliseconds. So if you see, the years cancel, the days cancel, the hours cancel, the minutes cancel, the seconds cancel, and I'm left with milliseconds. This is the easiest way to convert, and it's called dimensional analysis. You have to be mindful of your conversion factors, so that's why it's essential to know them, like commit it to memory. And this is an easy problem to begin with because most people are familiar with how many days in a year, how many hours in a day, how many minutes in an hour. So you have to, I can't stress how important it is to know your conversion factors. Cancel out units. So if I want to cancel out years here, which is over there, right here, you want to keep it on the bottom. If I want to cancel out days, I want to put days on the bottom. If I want to cancel out hours on top, I want to put it on the bottom. If I want to cancel out minutes, I want to put it on the bottom. So cancel out things, you put it in the bottom, okay? And that's another thing. And the way you compute this would be you would multiply everything on the top and divide by the product of the bottom. So I'd multiply 15 by 15 times 365 times 24 times 60 times 60 times 1,000 and divide by 1 times 1 times 1 times 1 times 1. Okay? When I do that, I end up getting, with the appropriate amount of sig figs, I get 4.7 times 10 to the 11th milliseconds. So let's do another example. 5,400 inches is how many miles? So always start off with what they give you, inches, and then start canceling out units. So you have to be mindful of your conversion factors. So I know that there is 12 inches in 1 foot. So what cancels is my inches. Then I also know that in 1 mile, there's 5,280 feet. And I cancel out the feet. So what am I left with? Miles. So I'm done. So I'm going to do 5,400 times 1 divided by 12 times 5,280. I end up getting 0.085 miles. More practice. 70 miles per hour is how many meters per second. So you're going from miles per hour to meters per second. So you notice both your units are changing. So we need to be mindful of that. So let's begin with the number they give you as 70 miles per hour, right? You're going to do your dimensional analysis now. If I want to cancel out miles, I need to put miles on the bottom. And I know that in 1 mile, there's 1.609 kilometers. How did I know that? I'm committed to memory. The miles cancel out. I'm left with kilometers. So I got to keep going because I need to get meters, right? So I also know that I want to cancel out kilometers, so I'm going to put kilometers on the bottom. And I know that in 1 kilometer, I have 1,000 meters. And then my kilometers cancel. I'm left with meters over here, so I'm happy, and I'm going to leave meters alone on the top. I'm going to worry about now to cancel out the hours on the bottom here. So if I want to cancel out hours on the bottom, I need to put hours on top here. And I know that in 1 hour, there is 60 minutes. So what happens is my hours cancel, and I'm left with minutes. But I need to get to seconds. So I need to keep going. I know that I need to cancel out the minutes, so I'm going to put minutes on top. And I know that in 1 minute, there is 60 seconds. So I can cancel out the minutes here. So what am I left with? Meters per second. Again, meters per second. And that's what I wanted, right? So I know I'm done. So I calculate the top, so I multiply the top, multiply the bottom, and then divide. I end up getting 31 meters per second as my answer. So what is dimensional analysis? You're going to cancel the units either top and bottom, all right? So that's just what you got to pay attention to. 16 meters cubed is how many centimeters cubed? Well, this one's a good one to practice is because you have cubed units, right? So let's start with the number they give me is 16 meters cubed. So if I want to cancel out meters cubed on the top, I need to put it on the bottom. And I know that in 1 meter, there is 100 centimeters. Because remember, centi means 100 cubed, right? But you got to understand that if we're cubing these units, you have to cube your number as well, okay? So what you're going to do is 16 times 100 cubed divided by 1 cubed. So if I do that, you end up getting 16 million centimeters cubed. So that was my point with this slide. If you're doing cubes, you have to cube the conversion factor. So let's just do one density problem. It's going to involve density conversion. So they give me the density of aluminum in grams per centimeters cubed. I need to get it in kilograms per meters cubed. So I start off with this, and you want to get to kilograms per meters cubed, okay? So we're changing both units, top and bottom. So let's start off with what we have, 2.70 grams per centimeter cubed. Let's focus on the grams first. So I need to cancel out grams, so I'm going to put it on the bottom. And I know that there's 1,000 grams in 1 kilogram. So my grams cancel. And I'm left with kilograms, which is what I want. So now I'm going to focus on my centimeters cubed. Centimeters cubed on the bottom here, so I'm going to put it on the top to cancel. And I know that there's 100 centimeters in 1 meter cubed. But remember, if I cube the unit, I got to cube the number. So it becomes 100 cubed over 1 cubed. And then my centimeters cubed cancel, and I'm left with kilograms per meter cubed. And that's what I wanted, right? So multiply 2.70 times 100 cubed divided by 1,000 times 1 cubed. You end up getting 2.70 times 10 to the third kilograms per meters cubed. This is your try it on your own slide. I'd recommend you to practice. The answers are provided. And remember, practice makes perfect.